Good morning and welcome back to Python, and today's topic is going to be Python args and kw args, which means keyword. Kw arg means keyword argument and arg means arguments, right? So now arg means not non-keyword arguments and kw arg means keyword arguments. So let's get quickly started with both of them, right? So here is my spider. Right, I'll quickly get started with it. For example, let's say to start with, I'll give you some examples and I'll just define it, right? For example, in this lesson, we are going to learn about Python args and kw args and their uses and their functionalities. In programming, we define a function to make it reusable code that performs similar operation. You know that. To perform that operation, we call a function with specific value. Every function has a specific parameter and has a specific value, and that value is called function argument in Python. For example, if I say define, let's say about define add me, right? So this is the function, and if I say I am accepting two arguments here, a and b. Now these are known as two function arguments. Add me is a function in Python that accepts two arguments, and now what I say, I will say return, or we can say print, right, a plus b, right? So this is it. So I can now say I'll call this function add me. If I don't supply any argument, I'm getting this, right? So now you can clearly see. Okay, let me call appropriate names. So now add me missing two required positional arguments, right? A and b means that if your function is accepting two arguments, please supply two arguments. I'll supply 10 and 30. Now I get the sum is 40. So that's not the case. The other case is we do not have luxury of passing more arguments. For example, if I today decide to pass more than two arguments or three arguments or four arguments, so now what if I pass one more argument? So it is going to throw an error right here. Add me takes two arguments or two positional arguments, but three were given. Why are you giving three arguments if only two are accepted? Now it's as simple as anything, right? So you should not give three arguments, but it is now our job to make this function mobile, or we can say if this function has a limitation that this function can add only two numbers right here, right? And in order to cater that, right, in order to cater that, how do you cater and how do you basically make it multi or n, you can say n number, and we can also say that infinite numbers or n numbers can be passed to that function so that it adds that. Now what I do, I will use two different things right here, right? And I'm going to define both the things right here, and both things that we are going to use is, I'm just defining them for you. Please take a note while I define things, right? Okay, so I am going to define, number one is args, which is arguments, and number second is kwargs, right? So we have arguments and we have kw arguments. Now what is args? We call them as non-keyword arguments, and here kw args is known as keyword arguments, right? So now what is the difference between non-keyword arguments and keyword arguments, right? So that you are going to understand in a while. For example, now if I make it non-keyword argument, that is single asterisk, and I call it num, right? Now I have to add this num now, right? And this num has many different things right here. So for example, if I pass 10, 30 and 10 here, now what if I print num? Now you can see, right, if I print num now, what it has given me, 10, 30 and 20. Now it has converted my whole number to a tuple, right? I can see, right? So it has converted everything to a tuple. Now we are supplying number of arguments, right? And everything is being converted to a tuple. So now things to remember that you got to remember for the entire life, that arguments pass variable number for non-keyword argument list, and on which operation of a list can be performed, right? You have to understand this. And this is what makes the function flexible. Now you know how to add how to add tuple. I don't have to show you that, right? Do I have to show you that? Okay, are you serious? Okay, I'll show you that also. But yeah, since you know now, because you have received a tuple, right? So since you have received tuple, you can know easily decide how to add that tuple, right? So let me say, for example, I do this. I declare a variable sum which is 0, and I say for n in num that we are receiving, because we have to now iterate through, because it has converted 10, 20, 30 has been converted to a tuple. Now I'll have to iterate through that tuple. So I can say sum. Hey, sum is already defined. Whatever is in sum, keep it in sum, but add extra. I'll say sum plus sum is equal to n, right? So now what will happen? The first iteration will take place. 10 will go in num. It goes to n, and sum is 0. Now sum is 10. Second iteration, sum is 10 plus 30. That's 40. Third iteration, sum is 40 plus 10, 50. So it's so on and so forth. It'll keep on going, right? And now if I print sum at the end of the loop, now what is going to happen, right? So let us see. We are getting the sum is 50, or you can say print the sum of, you do not know how many values you have supplied. Yeah, you can even know that. How do you check the length of tuple? By applying len. You can say the sum of len, and I will supply num here, right? I'll check the total length of the tuple because it's been converted to tuple. The sum of len, which is the num, right? And I will just print it like this, of num is, and I will take this sum right here, and I'll put f in front of it, means format. The sum of 3, now you can say 3 numbers is 30. The sum of 3 numbers is 50, 30, 40, 50, right? Now you can supply as many as you want. I want to add 10, 5, 6, 7, 8, 78, 19, 1000, whatever you want to. And the sum of 9 numbers is 268. So now by this we have been able to make our function flexible enough so that it can return me the sum of whatever number I want. Now I can get this thing in return. I don't want to print, I'll say return, right? I can easily say return sum, right? So now we're returning sum, as simple as anything. So I'll say sum is equal to get the value of this, and I'll say print sum, right? And where do you get the length? I'll also get the length, don't worry. All right, so now you have 268. So now this is how you can make your function flexible. That's why I said they are non-keyword arguments, right? Now if I show you another demonstration for keyworded arguments, I can show that quite easily, right? All right, so let me show you another demonstration for keyworded arguments, and that is, now first let me define them. Python passes variable lengths to keyword arguments, right? You know that. Now what we can pass length and key, we can pass a key and a value pair. I will say define. Okay, let me define it first. You've seen keyworded argument, non-keyworded arguments. Now we'll say non-keyworded arguments have been seen. Now they are keyword arguments. 1, 2 asterisks and data. Now it's as simple as anything. Key and a value pair. We are taking key and a value pair. Whatever we are supplying is being taken as a key and a value pair. You mind if I print the type of data? The type of data is, now we have to call this function. Now I'll say intro, and let me call this function, and you can clearly see the type of data is dict, dictionary. Now what if it is single asterisk? What is the type here? The type is tuple. Now you can see double asterisks will convert and take the numeric or any data. It's going to take the data as numbers. All right, as I said, it is going to take data, whatever arguments you are going to pass. Dogs have started barking. I don't know what to do with these dogs. They've just been barking the whole 1 month of lockdown, and they have that energy, right? And they even don't fast. Do dogs fast? Okay, let me know in the comment section. Bye bye. Okay, not to you. Bye bye. It's to dogs because they have gone. Right. So type here is for double asterisk, which is keyword arguments. Right. Oh, I spelling mistake. I do a lot of spelling mistakes, right? So type here is dictionary, and for non-keyword argument, right, is tuple. Now you can see it's tuple right here. Now what do you handle here? For example, because now we are handling two things. We are taking two things. It is going to be key. It's going to be value. Now we can take that as well. We can say for, let's say k is key and let's say v is value, for example, and we are going to take it in data dot items, right? When directly taking it in data dot items, and now what I say, I want to print, right? And what do you want to print? I want to print, let's say about key. So I will print key, which is going to be, let me print a formatted string which is going to be k. This k, which because the first asterisk is key, which will go here, and second asterisk is value, which will go here. So I am going to print key, and I am going to print value, which is v, right? And in between I am going to keep is, right? So let us start printing, and let me call the function directly. Alright, so let me call the function directly, and I'll say intro, and I will pass first, first name is equivalent to Fahim, which is key, and this is value. So this goes here, this goes here, right? And when I print, key is printed, that means we are going to print first name is equivalent to Fahim, and first name, that is the key, and then is Fahim, right? So we are going to get first name is Fahim, and we can see this, right? First name is equivalent to Fahim, and let me have last name as well. So I will say last name is equivalent to KHA and Khan, right? All right. So now you mind if I just take it to result? Oh no, we don't have to take it to result because we're printing here. Now we are getting first name is Fahim and last name is Khan. Can we supply? Now we don't have any limitation here. We can supply as many values as we want to supply. So there is no limitation at all. Go ahead and supply what you want to supply, whatever you want to supply, and up to the extent possible under you. And now I can say last name is equivalent to Khan, and I can say, for example, phone. I can say contact. Yeah, I can say key is phone, and I will say 9419441234. Now I can print. Now you can see it keeps on adding when you do not have any limitation. Supply what you want to supply, right? And I can say address. So let me expand it, and I can say address is equivalent to residency road, right? Now you can supply address as well. Now first name is Fahim, last name is Khan, phone is this, address is. Now you're making your function flexible enough to respond and give you the result as per your own liking without having a limitation. Now things to remember, single asterisk and the variable names means it's args, which is non-keyword arguments. It's going to take data as tuple or convert your data to tuple, and double asterisk, which is first asterisk is a key, second asterisk is a value, is going to take data as a pure dictionary, right? And what is the limitation? Does not have any limitation. It's going to just bifurcate key and a value pairs as per your likings. You can call it 1 time, you can call it 10 times, you can call it 20 times, doesn't matter, right? You can see that you are getting it executed like a pro, right? So now this is it, what we had for asterisks, which is args and kwargs. So now to carry on with the different things, will go back to lambda function or will go back to lambda expressions and see how do you apply lambda expressions, okay, using args and kw args. And for that I'll just show you it, because I have an old version right here, 3.7. I need to get 3.7.3 and higher in order to work with that, right? So I'll go to my IDE. Now this is an IDE here. So let me clear it up. Okay, now this is my IDE. Let's say hello. Alright, I'm getting hello, right? You know that. You'll say, sir, we know this already, and I know that you know this already. But yeah, let me take a lambda. So I define a lambda function and I say, hey, this is my lambda, but the variable is going to accept is going to be an args variable, right? And what do? You call the inbuilt function sum of. Sum is an inbuilt function of Python. I call this sum inbuilt function of Python and pass args to it. And where is the data? I'll say data is here 1, 3, 4, 5, whatever you want to pass as many as you want to pass. Oh, what have I done? Alright, so now since you have passed every single thing here, we have a syntax error. Why do you have 2 columns, right? I have only one. Now second error, I don't know. Alright, so lambda, what is the error here? Lambda, and we are accepting sum and these dogs. My god, what is args? It's num, right? Because whatever you supply will go to this variable here and you're adding them one by one, right? It should work now. So the sum is 20, the sum is 34, right? You can see the sum is 34. Let me do it in a separate file. I can say that result is equivalent to, then I can say print result, right? And now if I print result like this, I get 34. Or I can say the sum is, right, and then I can say this result right here, and I can use the formatted, I can use F to format the string, and the sum is 34. Let me get rid of the dogs or dog barking. Alright, now they stopped barking and I am back. This is how we can use lambda functions with args and kw args. No, I haven't shown you kw args, right? Let me show you kw args as well. If I say lambda, now for example we are accepting kw args, whatever you call this, kw, let's call this kw, right? And it is going to give me this sum of kw, because it is now basically the dictionary. I'll say values, right? Kw, and it's going to extract all the values one by one, right? And it is going to give me values right here, okay? And now I pass those values, right? And value is going to be key, and value is going to be key and a value pair. 1 is equivalent to 1, 2 is equivalent to 2. So let me see. Now you can say result, what is the result? And for that I will print result, right? Okay, the name result is equivalent to, okay. You are getting 3, right? Because you are doing sum kw values, you are doing sum of 2 values, right? Which is 1 and 2, right? You're not taking basically keys, you're taking values. If you say keys, then it's going to be concatenation, right? It's not supported. Sum is not going to support that, right? So that's why we are taking values. Value is 1, and here the second value is 2. So that's what we are doing, right? We know that what is dictionary? Key and a value pair. When I say kw.values, I'm forgetting key, targeting values, forgetting key, targeting values, right? And now we are taking key and a value pair. This is how we can use lambda expression for keyworded arguments, right? And can we do something else? Okay, let me do something else for you. If I take now my lambda expression is accepting one variable which is x, another variable which is asterisk, I don't know what the variable is, third is y, and I say y is equal to 0 initially, right, and z is equal to 0, which is also initially, right, and I say I need to go and do x plus y plus z. I need to add these three numbers, right, and if I'm adding, I need to supply. I can supply 1, right, and I can supply. Now we have to supply here something, right? 2, 3. Okay, let me see the result. I know it's going to be an error, right? Because you have to now y, it's an asterisk here, right, and that's why I'll say 1, and I will say y is already 0, so I'll say y is equal to 3. Z is already 0, I'll say z is equal to 3. So this is how we can solve this, and we're getting the result 6, 3, 4, 5, and 6. Y has already been something. If y is already something, then you have to reassign, because it's a variable. Variable is something that varies, right? You cannot say 2 because it already has 0. So this is how you do it in lambda expression. All right, and you can supply many different things, like you can supply factorial, right? And you can supply many different things, right? You can convert a list from lowercase to uppercase, right? And you can do many different things. So let me show you. Let me see the timing first. We have a good amount of time remaining, right? Let me create a list, right? And let me say that I am going to create L is equal to list, right? And I am going to use map here because I need to map them, right? LAMBDA. I say lambda, right? And it accepts one argument, that is x. Whenever we call this lambda function, it accepts one argument, which is x. And I want to take, right? I want to take this x and I want to do upper. I want to convert it to upper, upper, uppercase, right? I repeat, when you call this lambda function, you supply value in x, you take that x and convert it to uppercase, and what you do, the values are going to be as follows. So let's say I am supplying 3 values, which is going to be small cat, small dog, and small cow, right? So let me close this map here, and let me print the L here. Let me print L. Now you can see you're getting 2 times. I don't know why we're getting 2 times. I don't know. So let me try it again. No, we're getting it once. So we have converted them to uppercase. That is cat, dog, and cow has been converted to uppercase. So this goes to x, converts, and gives back a result to uppercase. This is what you can use single line statements to apply. You can apply single line statements to achieve multiple results or multiple iteration results, right? So that's what you can do. And what is that we can do again? We have capitalize also. Capitalize. I am bad at spellings. Okay, capitalize. Now you can see that I have misspelled it. Capitalize. Okay, fine. Now you can see first word of cat is capital, D is first word capital, and C. You can apply these things. Capitalize means turning the first word capital. Uppercase means completely capital. Right? And what else can you do? Right? So these kind of things, I don't know why they show error in Spider. Now if I run the same using Spider here, no, it's doing the same thing here, right? So no error is here. So let's do using Spider. I'm doing it using ideally just to give you a better view, because it's a bit small here, right? It comes a bit small, so that's why I'm going to give you a better view in Spider. Okay, in ideally, right? So let me try a few more things. And if I don't do this, for example, if I'm not doing map, now what are you going to get, right? So you're going to get an error because you are expecting 2 arguments, right? So that's where you have to actually map it down. You saw how we map right? We have already shown map in the previous video. In case you have jumped in directly to this video, I reckon you going back and checking all 3 videos of lambda expressions, right? Alright, can we apply filter, right? Let me show you all 3, zip filter and this. I'll say L is equivalent to list of things, and I'm applying filter, right, on lambda. I'm applying filter on lambda, and I'm expecting one argument, which is x. X is one argument that I'm expecting, and I can say O. If there is O in x, if you find O in x, return true or return false, right? Wherever you can find now O will be returned back to you. So let me show you how. We have 3 things, cat. Let me copy it because I already copied it. So let me copy it. Now you can see C, D, O. That is cat. Cat has no O, dog has O, and cow has O. So let me see how it runs. Okay, I have to print. I'll say print L. Now you can see you're getting dog and cow. Only O is present in dog and cow, because I told you filter is going to take only true from the function and not false, right? Okay, now you can say that if there is O in function, it returns true, it returns false, because you're using filter. So does cat have O? No, cat does not have O. Does dog have O? Yes, dogs are barking behind me, and they keep on barking the entire day. I cannot even, would you believe that I don't even dare to record? I have to wait for hours and hours so that they stop barking as I start recording. I have to cancel my recording, I don't know, many a times, because of these dogs. So I don't know what made these dogs bark amidst COVID-19. Maybe they're not getting ample amount of food. It doesn't matter. Humans are not also getting ample amount of food, right? And yeah, they are most probably listening to me. So we are going to avoid them, right? Otherwise, I'll not be able to prepare the lecture, because that's their routine job. That's what they do day in and day out. They heard me. Right, so this is how your filter function works. Now I will show you another function, which is reduce. Alright, I don't know whether I have that, so I'll say from func tools is included in Python. From func tool import reduce, yeah, it's already there, import, right? You can import it directly. I can call L is equivalent to reduce, right? I'll tell you what this reduce does also, right? I'll say that L is equivalent to reduce, and then I call lambda. Lambda is just an inline function you're making. You can make it, I call A, this the parameter I'm expecting. I'll say, hey, I want to reduce, I want to take X and format, right? And format something like this of A that I have supplied. Whenever you call lambda function, you are supplying an argument which goes in this A, right? And then you take that A. No, why are we taking this as X, right? I have to take okay, we can say I am taking it as X. Let me call this as ACC, and let me say X in ACC, all right, divided by X, all right, and that X is going to be, for example, cat, dog, and cow, right? So let me print L and see what this reduce does. Okay, we have an invalid syntax right here. Why do we have an invalid syntax? Right, okay, I just why because we have to accept 2 variables. Yeah, I am accepting only 1, so I am expecting 2 variables right here. So whenever you call this function, you have to supply ACC, and you have to apply X as well, and then you say format ACC divided by, or it's not divide, basically it's OR, sorry, not divided by, it's OR, and then I say X, and I should get this in between. It's just, I'm just dividing them in between. That's all what I'm trying to do. I should get result like cat, this cat pipe down to dog and pipe down to this, right? So you can see we're still having this error right here. Okay, ACC and X we are accepting, and then I say if I'm expecting 2, what is this X doing here? Nothing, sorry. Now we can say you're getting cat pipe down to dog, right? You're just getting for example, if you're developing a website tomorrow and you want a nice menu bar, you can use this reduce function to just reduce and format it properly, right? So it is basically going to format it properly, right? And there are more things that we can do using reduce, right? And you will see that in the concurrent lectures, even if you're not getting 100%, right? So you can change it. I don't want pipe down, right? I want let's say about plus. You can use reduce to reduce it to plus. Now you can say cat plus dog plus cow. If you want minus, you can say cat minus dog minus cow. So it's just like you're formatting a string, and for that you are calling this reduce. For example, if I don't call reduce here, so we are going to get actually the lambda function completely, right? Say, hey, I need a reduce of it, right? What do you need? All right, for example, what you pass is basically goes to ACC, which is cat, dog, and cow. Now, if you just take it, because you're not taking it as asterisk, or you're not taking it as a as a key arguments or KW args or args, you're just taking it as a reduce, right? So reduce is going to reduce it to what you want in between two to come, right? You can do it in function using loop as well, so that's not an issue, right? But yeah, reduce is also there. You can use reduce, and let me show you a few more functions right here, right? And few more things that we can achieve using the same lambda expressions. Capitalize we have seen, reduce we have seen, filter we have seen. Okay, let me say, for example, I want to get even numbers. I can say even is equal to lambda of x. Now, whenever you define x, you have to supply x. You can say x divided by 2, right? If x divided by 2 is equal to 0, then the number is even. Otherwise, the number is not even, right? So you can say even is equal to this. Now, if I call even and I say 10, now you know that you are going to get it. So there's you're not getting anything, right? Because you have to print. Now, how do you print? Because you have to print true or false. You're getting true, right? So I'll say 8, you will get true, right? If I say 7, you should not get true, you'll get false. Yeah, that thing is working absolutely fine. But what if I want to supply a list of things, right? So for example, I have to supply, let's say I call this function even, and I say I want you to go and I want you to take list of things rather than taking a particular thing, right? I can say that, right? You can take, let's say you are going to take a list comprehension. Let me take L is equal to a list comprehension, and I use this filter here. I will say even, and let me say range is equal to 11. So 11, that means it's going to go till 10. Now they have started barking again. Ignore them, right? I can say now print L, right? Unless I supply, it's going to show an error, right? Why? Because you have called even, so it's not the way you call this even, because you have to supply an argument. You're not supplying an argument here. Yeah, if you want to supply an argument, you say I'm supplying range. That's also done, but yeah, I don't want that, right? But it's going to show me an syntax error. Now what I do, I say I need to filter, right? I need to apply filter. Now you can see you'll get true and false of all. Now you can see that 0, 2, 4, 6, and 8 are the numbers which are even, right? Because it returns true. You know that filter is going to return as true only, right? And if you don't use filter, right, then you'll have to pass any number, right, to the function. But yeah, in case you are using filter takes two arguments, the list, right, and the function, which is in our case lambda function. And had it not been lambda function, you can make it you can make sure that, I mean, it can be a normal function that returns the range of things, right? So, but yeah, in case we are learning lambda functions, so we can use pairs as well, right? And we can even use reduce. I'll say import reduce, or import func tools, or you can say import from so you can say from func tools import something pretty funky, right? So I'll say from func tools import reduce, right? So now we can use, so let me compile it and see what I get. Yeah, now we are getting it. So now I can say that since I have been able to import it, so I'll say pairs. For example, if I am having pairs and those pairs are a list and a list containing a tuple of things, so that can be also done. So now we have pairs here. For example, we have 1 and 1 is A. We have 2 and 2 is B. And we have 3 and 3 is C, right? So these are pairs. So if I say print pairs pairs, so you'll get all those pairs, right? It's a list. List contains a tuple, and tuple contains some pairs, right? So now if I want to use lambda expression to reduce, right? And now what I can do here, I will say result is equivalent to, and now I can use reduce function, and I'll pass pairs to reduce. I'll say lambda, and I'll say ACC, right, which is pair. So now it is going to accept two things, which is ACC and pair, right? And I'll say you do one thing, take that ACC parameter that's been passed to you, right, add that to pair 0. Now what is the 0 of pair? So now you can say 0 of pair is, this is the first of pair and this is the 0 of pair, right? Now 0 means the value. I want to take only value, right? And second, I don't want to pass, right? A pair of 0, and I'll say ACC plus pair of 0, and second thing is something that I do not want to pass. I'll say pairs, and second thing I don't want to pass. Now I'll get the addition of pairs, right? So let me compile it and see. Okay, what is this pair doing here? Okay, sorry. All right, now let me print result. I'll be able to get the result 6, right? That is 2 plus 1 plus 3 is equal to 6. Now what is this reduce doing here, right? It is basically taking key and a value pair, just like this. Reduce is taking this as key and this as value, and you are taking only the 0th element, that is this, right? And what you are doing, you're reducing it and adding to the pair 0, right? And this is the list we already have. You're supplying the list here, right? Because you take two arguments, ACC and pair. ACC is supplied, which is pairs, which is the complete list here, and the second argument which you are taking pair is not being supplied because I don't want that. That's why I say I want the 0th element to be added to ACC, and then I get 1 plus 2 plus 3. So this is how we can use the reduce, right, to do what we want to actually do and to achieve what we want to achieve actually. Right, we can do it without reduce as well. Yeah, for example, we are having, let me say we are having pairs. Let me not import anything. For example, we are having those pairs right here. All right, so can I do something like that? S is equivalent to sum of, I can say sum of x is 0. So I am not supplying anything here, right? And I'll say for x in pairs, right? So I can do that, and I can print my sum. I'll say print s. Now this is what I can do for, okay, Okay, let me see. Brace error. We have to use proper braces. What braces am I using? So we are getting 6 right here, right? What happening for x in pairs? You are taking x, right? In pairs, you are taking everything in pairs. Pairs will loop through, but yeah, you are going to take only the 0th element. Now, if you take x 0 1, x 0 1, x 0 1, but yeah, here you are doing the only 0th element because pairs is going to iterate as x, right? So these pairs are going to iterate as x here. All right, so now once you go to pairs, x is 1 and a, but you are going to take, oh, I don't need a, I need only 0. So this is what you can receive without even lambda expressions. You can receive it like this, right? And you can say, for example, x, for example, if you are running for x in pairs, you can do this sum x. Now supply x. You can say sum x. If you say x, you're going to get an error because you're supplying strings. Sum x for x, right? And I will say comma, and I can supply this blank argument. I'll say blank, nothing. Now you can still get 6, right? So this means I'm not supplying anything as a second argument. I'm only taking first argument. Now this can also be done, right? And there are many different things that you can do using lambda expressions, right? You can return many different things, right? You can calculate many different things, right? And for example, if I have this C is Celsius, I have some temperature which is degrees Celsius, right? I'll say 39.5, and then I'm having 37, I'm having 37.5, and then I'm having 39. So this is degrees Celsius. And if you want to get the Fahrenheit of the same, I'll say, yeah, I can get the Fahrenheit. I can convert it to the Fahrenheit scale without even using any different thing. I'll say map. Right, now see the map. I'll say LAMBDA, lambda. One expression is expected, one argument is expected, and I take that argument and convert it to float, right? I convert it to float, but yeah, what I do, I convert it to float and do 9 divided by 5. This is 9 divided by, this is a formula for converting into x. This is the formula for converting to Celsius plus 32, and I'm going to apply this argument here, right here, that is C. Now, can you please give me the map of it? I can say print f. I know that you will not be getting 100% of it, right? You're getting map object here. Okay, let me print it. Okay, I have to print the Fahrenheit scale. Why haven't I been able to print? I have supplied C, so let's say map of lambda x, and I say float, convert it to float, but do 9 divided by 5 into x that you have expected or accepted, multiplied by x plus 32, and supply Celsius, and then you have to print the Fahrenheit scale of it. So you're not able to print the Fahrenheit scale. Why? You are getting a map object. I know that you're getting map object, but why aren't you able to print it, right? I want you to print it. Can I print f is equivalent to map? So it should be able to print map of lambda x, then start float, convert it to float, 9 divided by 5, close it down, asterisk plus 32, and take what you are supplying as Celsius. So is there any error? 39.5, 37, right? So let me say we are having 37.0 here, 37.5 is here, and 39.7 is here. Only the floating variable, so maybe that is going to help us. Yeah, we're still getting map object right here. We should be able to get what we want to get, right? Let me see what went wrong here. C as in Celsius. We have 39.7, and I do map. I call the map directly lambda. So we are expecting one parameter, which is this C right here, plus 32. Okay, this 9 Why don't I get it? So if I do 5 divided by 9, so will I be able to get? No, I'm still getting a map object, right? So maybe something wrong that I am doing. I'm doing something wrong, right? Or maybe I have to navigate through it, right? Or maybe I'll have to loop through it, right? 9 divided by 5, so it's absolutely right. I'm not doing anything wrong, right? So let me take it float. 9 divided by 5, right? And then I have this asterisk x into x plus 32, and then I apply the degree Celsius right here. It should be able to give me Fahrenheit scale, because it should be able to give me the list here, right? So now what if I say I need to get only, just a moment, so I will say C. Yeah, map must have at least 2 arguments. So the first argument that I'm giving to map is this, and the second argument I'm giving is C, but it's not taking it. Let me do it once again. Map is equivalent to lambda, right? And I say x parameter is accepted, and I say I need to convert it to float, right? And I need to convert it to 9, and I say I need to divide it by 5, right? And close it down, right, into x plus 32, and supply Celsius as the second argument. So it should be able to give me, okay, let me take it to spider and see what do I get here. I'm still getting the object of map, right? And now why am I getting the object of map? Maybe I'll have to take it to list. Maybe I'll take it to list. Let me convert it to list first, right? And then see what are we getting. Alright, so let me take it to list. Alright, yeah, we are getting now Fahrenheit. We are not taking it to in the list, right? At times debugging is going to help you. Now this is on the Fahrenheit scale. What we have done, just single line to convert as degree Celsius scale to a Fahrenheit scale, right? And I can say print F, and I can say F, which is Fahrenheit. Are you getting, right, on the Fahrenheit scale, right? List of things. So this is how we can use map to map it down, right? Two arguments, right? And yeah, you're not going to get 100%, even if you're getting 60%, and that is going to be much better for you, right? 60. And as we go along the class and as we progress, we are going to get, it's very easy. What you are supplying here is this x, but you're mapping it down because you're first taking map of 2 values, right? So that's why 1 value and second value, right? It's easy, but yeah, initially it's going to take good amount of energy for you to understand what is happening, all right? And I'll show you what is happening in a very nice way. For example, if I have 0, 1, 1, 2, 3, 4, and we have 5, we have 8, or we can say we have 3, we have 5, we have 8, we have 13, we have 21, we have 34, and we have 55. For example, we are having these numbers from 0, right? And I want my result to give me a filtered. I want my result to give me a filtered list of things, which is I'm going to accept 1, but yeah, what I do here is the main key. Now this is the body of the lambda expression, right? And in this body I say x modulus 2 if the remainder of the value supplied in the list is going to be divided by 2, right? And you take that here and give me the result. Now you can see that we get a different sort of result. Double comma, I'll have to get rid of the comma here. Now we're getting 1, 1, 3, 5, 13, 21, 55, right? Filter only returning true. Those who are divisible by 2 are being returned, right? 1 is 2 times, so you are getting 1 2 times, 3 is there, 5 is there, 13 is there, 20, which are not which are, basically which are not divisible. So you're getting all those values here. You can see whatever it is, you can say is equal to 0, and you're going to get opposite of that, right? Divisible are only 0, 8, 0, 2, 8 and 34, and not divisible, you can say not divisible, and not divisible are 1, 1, 3, 5, 13, 21 and 55. You can get the filter, you can use filter to get, if I say map is going to return me a different thing, true, 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 and false, right? You can see false, 1 is not true, 0 is not, 1 is, and then we have another value, not. Now you can see all the values which are not, or you can say is equal to true, it is going to return me, right? Now you can see 0, 1, 1, 0 is divisible, 1, 1 is not, 2 is, 2 is divisible by 2, right? And 3 is not, 4 is not, and this is 5 is not, and 8 is, that's why we're getting true here. That's what map is doing. Zip is not going to do anything, it's not going to return anything, right? So zip is not of use here. Zip is going to match 2 in parallel, right? So but that's why we use filter here if you want to get the result itself instead of true and false, right? So now we're getting the result itself instead of true and false. And let me show you the last thing which is going to make reduce clear to you. I will say import, I'll say from func tools, import, now the dogs have started barking again, from func tools import reduce. Now this is going to clear every problem you have against reduce. So I'll say reduce, L is equal to reduce, I'll say L is equal to reduce, and I call the lambda, right? And here I go, it's going to accept two variables x and y, and what I do x plus y, but now I am not doing normal x plus y, I'm calling the reduce function right here. And now the values that I am going to pass are, for example, 47, 11, 42 and 13, right? So now if I run it, we are going to get nothing because we are not printing. So let me print L here. Now we are getting 113. Why did I get 113? Now is the value here 113? Now you can see if I take calculator here, and say how much is 47 plus 11 plus 42 plus 13, so that is 113. So we are getting 113, and that is the correct answer, 100. Now why are we using then reduce? Why aren't we just taking it directly and then printing it, right? So you can see you're getting a list of things. You're not using reduce to basically reduce it to a final result, right? Now once I say reduce, you're not getting list, you're getting the final result of list of things that have been supplied, right? And now I'll tell you the diagram which reduce works. How does reduce work? Right, I'll take the same into MS Paint and show you how does reduce work right here. Now the first value supplied is, so let me take these values right here, right? So let me take it. Okay, so now this is value number 1. I'll say value number 2, it is going to give me value number 3, it is going to give me value number 4, and it's going to give me value number 5. So we have total 4, and then we have here, and another we have here, and another we have here. Now let's see what are we supplying. The first is 47. I'll write it down here, 47. What is the second? Second is 11. Fine. What is third? Third is 42. What is fourth? Fourth is 13. Right? Now see how reduce is going to do it for us. First it is going to take this plus this here, and it is going to take this plus this here. So now how much is 47 plus 11? It is going to be 58. How much is 42 plus 13? It is going to be right now you can see this here. Now 42 plus 13 is not going to help here, right? Because it is going to now give me something else, right? I'll just keep it like, okay, let me just get rid of these lines. How much is 47 plus 11? It is 58, right? And now you can see here 58 goes here, 42 comes here. How much is 58 plus 42? It is 100. Now we're going to have 100 here. Now how much is 100 plus 13? So this is how reduce is going to take. Right, this is how your reduce is going to work, right there, and it is going to come here one step ahead, right? It is going to be 113, right? So this is called as intermediate steps of calculation. I repeat, intermediate steps of calculation. So we have supplied 47 plus 11, 58, then we are going to take 42, add to 58, that is 100, and then we are going to take 13, add to 100, which is going to be 113. So this is how reduce is going to work for you, right? So now we have many different ways to handle reduce. For example, if I show you the reduce, we can say, let me say f is equal to lambda, so that you can understand it in much better. I'm going to accept lambda expression, two variables, right? And I'll say a if a is greater than b, right? If a is greater than b, I'll say else b, right? Return true if a is greater than b. If it is not, return b. So now if I just go ahead and print f, right? Okay, and now I need to supply some value. I will supply 10, 20, right? So I'm calling f, and I am supplying two values, which is going to be 10 and 20. 10 is A, 20 is B, so we're getting 20, right? Which one? A is greater than B? No. 10 is not greater than 20, right? Then give B. So B is 20. Now if it is greater, for example, if I say 30, you're going to get 30. Now you can see 30. 30 is greater than here, right? So now if I say I need reduce, I need the reduce, but I am not supplying normal arguments here. I am supplying to my lambda function, right? Reduce takes two arguments. One is what you want to call, that is the lambda function, and another is list. For example, I call 47, 11, 42, 102, and 13. Now see what are we getting? reduce print. Okay, I forgot the braces of print, right? So let me print it out. Now you are getting 102. Out of all, you can see what are you getting. First, is 47 greater than 11, right? Is 47 greater than 11? No, then give B. What is B? 11. Is 11 greater than 42? No. Then give B. What is B? 42. Is 42 greater than 100? No. Is 102 greater than 13? Yeah, then give 132. Otherwise, give 13. If I take it, for example, 12, then we should get 13 right here. So we are getting 47. Why are we getting 47? Because the greatest element is 47 right here, right? So this is how reduce is going to work, right? So, and this is the diagram. You have to keep it in your mind. Right, so this is how reduce is going to work. Let me show final time. Let me show you reduce in a single line, and I'll wind up today's class with that. I'll say reduce. I'm calling this reduce. I'm calling this reduce, and I'm calling this lambda function. I'll say x and y, and I supply x plus y here, right? And I'll say range 1, 2, 1, 0, 1, right? And now let us see how this reduce is going to help us. Right? Can I just say r is equal to, I'll say print r, right? So now we are getting 5, 0, 5, 0, right? So calculating the sum of numbers from 1 to 100. You are now calculating by this reduce. You're calculating the numbers from 1 to 101. right? And now if you say how many are from 1, what is the sum of numbers from 1 to 101? Get it? It's 5050. For example, you're going to use the same 1 plus 2, and then you will get 3, right? And then, right, you will get 4, 5 plus 6, and then you'll get so on and so forth, right? So the total sum, if you take 1, 3, 4, 5, 6, 7, 8, 9, 10, and you'll go till 101, the total sum is going to give you, right? This reduce is going to give you the total sum, right? And now you're supplying it range. You have already supplied range, which is 1 is going here, and 101 is going here. Then you are doing x plus y, but you are looping through it, iterating. So this reduce is going to help you to calculate the sum of numbers from 1 to 100, and that brings your lambda expressions to end, including the map, zip, filter, reduce, and each and everything. Let me know down in the comment section if you have some problems, if you want my help. And yeah, if you haven't got more than 60%, that's sufficient for initial, because you just started with all those things. It's going to be mix up of too many things, right? Understanding zip. Unless we do it in practically in a project, you're not going to get 100%. 60% is quite sufficient. And if you've got 60%, then I must congratulate you. And I say once again, thank you, and see you in the next class. Bye-bye. Take care. And yeah, we are going to start with object-oriented methodology, and that too high end from the next class. Until then, wish you good luck. Bye-bye. Take care.